Hi everyone, welcome to SR Math Learning channel. Today in this video, I'm going to discuss the functions chapter. So here from the basic level 2 till JE mains and advanced, I'm going to discuss with in different parts. So today in the first part, in part 1, we are going to discuss first basic definition. What is the definition of a function? So I'm going to discuss. So before writing what is the exact definition, I'll make you to understand what is the definition actually. ఈ ఫంక్షన్స్ అంటే ఏంటి అనేది ఒక్కసారి సో మన ఓన్ లాంగ్వేజ్లో డిస్కస్ చేద్దాం. సో వాట్ ఈస్ ద ఫంక్షన్? లెట్స్ సి థింక్ దిస్ ఇస్ వన్ సెట్ అండ్ దిస్ ఇస్ ద అనదర్ సెట్. ఇవి రెండు వేరు సెట్స్ అండి. సో హోప్ ఎవ్రీవన్ నో వాట్ ఈస్ మీన్ బై సెట్. సెట్ ఈస్ వెల్ డిఫైన్డ్ కలెక్షన్ ఆఫ్ ఆబ్జెక్ట్స్. సో హియర్ నేను రెండు సెట్స్ తీసుకుంటున్నానండి, సెట్ ఏ అండ్ సెట్ బి. సో ఈ సెట్ ఏలో రెండు కూడా నాన్ ఎంప్టీ సెట్స్. ఫస్ట్ సెట్స్లో లెట్స్ థింక్ వీ హ్యావ్ 1 2 3 4 అండ్ సెకండ్ సెట్లో ఏబి సిడిఈ. సో దీస్ ఆర్ ద ఎలిమెంట్స్ వీ హ్యావ్. ఓకే, సో హౌ కెన్ we define the function when we can say there is a function exists from A to B? So let us assume f is a function. f అనేది ఒక ఫంక్షన్ అనుకున్నాం, ఏ నుంచి బికి డిఫైన్ చేస్తున్నాం. సో హౌ కెన్ వి డిఫైన్ దిస్? ఎలా చెప్పొచ్చు f is a function from A to B అని? సో in set A for every element or each element of set A has a relation with a unique element in B. అంటే దాని అర్థం ఏంటంటే సెట్ ఏలో ఉన్న ప్రతి ఎలిమెంట్కి ఒకే ఒక రిలేషన్ సెట్ బిలో ఉండాలి. యూనిక్ రిలేషన్. సెట్ ఏలో ఉన్న ప్రతి ఎలిమెంట్కి ఈచ్ ఎలిమెంట్ ఆఫ్ సెట్ ఏ షుడ్ హ్యావ్ ఏ యూనిక్ ఎలిమెంట్ రిలేషన్ ఇన్ సెట్ బి. సెట్ ఏలో ఉన్న ప్రతి ఎలిమెంట్కి సెట్ బిలో ఒకే ఒక్క రిలేషన్ ఉంటే then we can say that f is a function from A to B. సో హోప్ అందరికి అర్థమవుతుంది అనుకుంటున్నానండి. సో దీని డెఫినేషన్ ఎలా రాయొచ్చు ఇక్కడ ఫంక్షన్స్ అంటే, లెట్ ఏ అండ్ బి బి టూ నాన్ ఎంప్టీ సెట్స్. అంటే అవి ఖాళీ ఉండొద్దండి, నల్ సెట్స్ కాకూడదు, నాన్ ఎంప్టీ సెట్స్. అండ్ FB a relation which associates each element of set A with unique element of set B. Unique element of set B. Then f is called a function from A to B. జనరల్ గా సెట్స్ ఎప్పుడైనా మనం క్యాపిటల్ లెటర్స్ ఆఫ్ ఆల్ఫాబెట్ తోటి డినోట్ చేస్తామండి. అండ్ ద ఎలిమెంట్స్ ఇన్ దట్ సెట్ వి విల్ డినోట్ విత్ ద స్మాల్ లెటర్స్ ఆఫ్ ద ఆల్ఫాబెట్స్, ఇంగ్లీష్ ఆల్ఫాబెట్స్. సో ఇది డెఫినేషన్ అండి. మనం ఫస్ట్ డిస్కస్ చేసుకున్నాం. So what is the definition? How to define a function from a set A to a set B? Set A lo unna each element ki there will be a unique relation. There should be a unique relation in set B. Then you will get doubt. Mari set B lo unna prati element ki undalsina avasaram leda? Avasaram ledhu. So set A lo matram prati element ki, for every element in set A, one and only one relation should be there in the set B. Unique relation undali. సో ఎందుకంటే జనరల్గా మనం అబ్జర్వ్ చేసిన ఇప్పుడు ఎఫ్ ఆఫ్ ఏదైనా ఒక ఎక్స్ ఇస్ ఈక్వల్ టు x² తీసుకున్నాం అనుకోండి, దీనికి డిఫరెంట్ డొమైన్ ఉండొచ్చు, అంటే డిఫరెంట్ ఇన్పుట్ ఉండొచ్చు. కానీ ఇప్పుడు నువ్వు ఏది సబ్స్టిట్యూట్ చేసినా, ఇప్పుడు 1 అనేది ఒకటి సబ్స్టిట్యూట్ చేసినాం అనుకోండి, సో 1² విల్ బి 1, బట్ నాట్ అదర్ నెంబర్, అంటే ఈ 1 తప్ప ఇంకొక ఆన్సర్ రాదు. ఇఫ్ ఐ సబ్స్టిట్యూట్ x ఈక్వల్ టు 4 వస్తుంది, అంటే ఒక యూనిక్ అవుట్పుట్ మాత్రం ఉంటుంది. ప్రతి ఎలిమెంట్కి ఒకే ఒక యూనిట్ అవుట్పుట్ అనేది యూనిక్ అవుట్పుట్. సో అందు గురించి సెట్ ఏలో ఉన్న ప్రతి ఎలిమెంట్కి సెట్ బిలో ఒక యూనిక్ రిలేషన్ ఉండాలి. దెన్ వీ కెన్ సే ఎఫ్ ఇస్ ఎ ఫంక్షన్ ఫ్రమ్ ఏ టు బి. సో ఇక్కడ మనం గుర్తుంచుకోవాల్సిన పాయింట్స్ కొన్ని ఉన్నాయండి. వీ హ్యావ్ టు రిమెంబర్ సమ్ పాయింట్స్ హియర్. సో ఇన్ దట్ ఫస్ట్ పాయింట్, ఇఫ్ ఏ బిలాంగ్స్ టు ఏ, ఇఫ్ స్మాల్ ఏ బిలాంగ్స్ టు ఏ అంటే దాని అర్థం ఏంటంటే ఈ ఏ అనేది ఏ సెట్ ఏలో ఇక్కడ మనం 1 తీసుకున్నాం కాబట్టి 1 బిలాంగ్స్ టు సెట్ ఏ, ఏ బిలాంగ్స్ టు సెట్ ఏ ఎలా తీసుకున్నా ఒకటేనండి. సో ఇఫ్ ఏ బిలాంగ్స్ టు సెట్ ఏ అంటే నేను ఇక్కడ ఎగ్జాంపుల్ ఎలా అజ్యూమ్ చేసుకుంటున్నా అంటే సెట్ ఏ వచ్చేసి ఏబిసిడి, సెట్ బి వచ్చేసి 1 2 3 4 5. సో ఇక్కడ ఏ నుంచి బికి రిలేషన్స్ ఎలా ఉన్నాయి. సో ఇఫ్ ఏ బిలాంగ్స్ టు సెట్ ఏ, the element in B which is assigned to A is called the image of A and denoted by f of a. దాన్ని ఎలా డినోట్ చేయొచ్చు అంటే f of a. అంటే దాని అర్థం ఏంటంటే ఇప్పుడు సెట్ ఏలో ఏ ఉంది, ఈ ఫంక్షన్లో ఈ ఏ అనేది సబ్స్టిట్యూట్ చేస్తే ఈ ఏకి సెట్ బిలో ఏ రిలేషన్ ఉంది అంటే 1 ఈజ్ రిలేటెడ్. సో ఏ కామ 1 ఈజ్ ద రిలేషన్, రైట్? దిస్ ఈజ్ 1 ఆన్సర్. అంటే ఏ నుంచి 1కి మనం రిలేషన్ తీసుకుంటాం. సెట్ ఏలో ఉన్న ఏ ఎలిమెంట్కి సెట్ బిలో ఉన్న 1కి రిలేషన్ తీసుకుంటాం. సో ఈ 1 అనే దాన్ని ఈ ఏకి ఇమేజ్ అని పిలుస్తాం. సో వీ కెన్ కాల్ ఇట్ యాజ్ ఇమేజ్ ఆఫ్ ఏ. సో హౌ కెన్ వి డినోట్ దిస్ వన్ ఇస్ ఎఫ్ ఆఫ్ ఏ. సో ఇఫ్ ఏ బిలాంగ్స్ టు ఏ, capital A, that means this element belongs to this set. The element in B which is assigned to A is called the image of A and it is denoted by B. Here second point, set A is called domain. Set A is called domain of F because those are input for that function. And set B is called codomain. Set B is called codomain of the function f. The set of elements of B, which are the images of the elements. So what I mean is here, see, I'll write one point. Later I will make you to understand. The set of elements of B, which are the images of the elements, which are the images of the elements of set A is called the range of F. దీని అర్థం ఏంటంటే, if I'll take the set A like this with the elements A, B, C, D, and set B I'll take like this. So 1 2 3 4 5. So A is related to 1, B is related to 3, C is related to 2, D is related to 4. So here this set A is called domain of the function defined from set A to set B. So this set B complete elements are called codomain. But from set A to set B, the elements which are related to which one means, see here, A is related to 1, B is related to 2, B is related to 3 here, C is related to 2, D is related to 4. So here this 1 3 2 4 means 1 2 3 4 are called range of F. What it means is the result, not all the set elements of set B, only the elements which have the relation with the elements of set A, that elements are called range of F. So here how can we write symbolically? This one is, if I'll assume let A is equal to set A is A, B, C, D. So you know very well, we can write the sets like this. And set B, if I'll assume like 1, 2, 3, 4, 5. So f of A is, we are getting 1. F of B, we are getting 3. F of C, we are getting 2. F of D, we are getting 4. So that's why here, domain of this function. So here A is the domain. Domain of F is 1, 2, 3. I mean, sorry, here A, B, C, D. A, B, C, D is the domain, and B is called codomain. So I'm finalizing the answer, and codomain of F is 1, 2, 3, 4, 5, and range of F. So range of F is only what we have: 1, 2, 3, 4. That's it. We don't have the 5 in the output. So that's why only these elements, the set of elements of this 1, 2, 3, 4 are called the range. So let's see some examples. Let's try to understand with more examples which are called functions, which are not called functions. So here I'm giving the different examples. So this is the set A, and this is a set B, and here one more set I'm taking. So this is one more set. So let's see the first example. Let's see the first example whether this is a function or not. So what we have: set of elements 2, 4, 6, 8, and here we have set B. So from A to B we are defining the function. From A to B we are defining the function, and the elements of set B is S, T, U, V, W. So here how these elements are related: 2 is related to T, and 4 is related to S, and 8 is related to V. So this is the first example. Second example is the set of elements we have, like same we will take for better understanding: 2, 4, 6, 8, S, T, U, V, W. So here 2 is related to T, and 4 is related to U, 6 is related to S, and 8 is related to V. So this is one example. So another example is, let's take like this. So this is a set A, and this is a set B. So in set A and set B, the elements are 2, 4, 6, 8, S, T, U, V, W. So 2 is related to S, 4 is related to T, 6 is also related to T, and 8 is related to V. Let's think. And let's take one more different kind of way of representing the same sets and relations. So this is a set A, and this is the set B, what we have. So here this is set A, this is set B, and elements are also same: 2, 4, 6, 8, and we have here S, T, U, V, W. So either 2 is related to S, 4 is related to T, 6 is related to U, and 8 is related to U, and 8 is related to W also. So here in every case, in every situation, the function is defined from A to B only. So the function is defined from A to B. The function is defined from A to B. Let's discuss whether these are the functions or not. If it is not a function, why? Reason. So if you'll see the first example here, A is related to, 2 is related to, from the A set A, 2 is related to T. So 2 is having a relation to T, and 4 is having a relation to S, 8 is having a relation to V. But 6, we don't have relation with any of the element in set B. So what is our definition when we can say a function f is called a function? A relation from A to B is called a function is every element of set A should consist a unique relation in the set B. But here 6 we don't have any relation. 6 we don't have any relation with the B. So that's why this is not a function. That's why this is not a function. So why reason? What is the reason it is not a function? Because 6 not having image. 6 not having image in B. So which is the 6 belongs to A. So that's why it is not a function. So come to the second example. So if you see example here, 2 is related to T, 4 is related to U, 6 is related to S, and 8 is related to V. So every element of set A having a unique relation with the set B. So that's why it is a function. Therefore, it is a function. It is a function. Next comes to third example. What is the third example we have? So 2 is related to S, 4 is related to T, 6 is also related to T, 8 is related to V. So you may get the doubt. So is there any chance different elements of A having the same image in B? Yes, it can be, because I'll take some small example here. F of x is equal to x square. If I'll put x is equal to 1, I'll get 1 square as the 1. If I'll put x is equal to minus 1 also, I'll get minus 1 whole square as the 1. So for the different elements, we may have the same image. So that's why this is a function, first of all. This is a function because different elements having unique image. So we didn't say that different images we should have in the B. So unique image means one and only one image should be there for the elements which are in the set A. So that's why this is a function. Comes to the fourth figure. Say A is having S, A is related to S, 4 is related to T, 6 is related to U, no problem. So 8 is also related to U, no problem. But for 8, we are getting the two images, which is actually wrong. For a single input, we will not get two different outputs in this function. So that's why this is not a function. This is not a function. This is not a function. So why? So it belongs to A is having two different images, two different images in B, two different images in B. So that's why, so this is not a function. So hope everyone understood. So how can we define the function? By using the relations, and this is the definition of different examples. So here I'll give you a small question for conceptual clarity. Actually, it is very small, but this is for the beginners. In the given figure, find the domain, codomain, and range. This is for beginners only, and so let's we draw the diagram figure here. So this is our sets. So these are our sets. Okay, this is set A, and this is set B, and the function f is defined from A to B here. So here we have, this is the P, Q, R, S in the set A, the elements, and in set B 1, 2, 3, 4, 5. So here P is related to 2, Q is related to 1, R is related to 3, S is related to 5. So this, how can we find the domain and codomain and ranges? I told you very clearly the set of elements from where the function is defined, that is domain, to where it is defining, it is codomain. So here A is the domain of F. So that is nothing but the elements of this domain is P, Q, R, S. So actually we should represent with small letters. So this will represent with small letters. So P, Q, R, S. So here we have domain as the P, Q, R, S. So B is the codomain. B is the codomain of F. So where we have the elements 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So range. So what is the range here? Range of F. So from where to where? So if you will see, F is taken here from A to B like this. P comma 2, Q comma 1, R comma 3, and S comma 5. So what are the elements? We got the outputs is 1, 2, 3, 5. So this is the range of the given question. This is the range of the given question. So let's see here one important point, that number of functions, how many number of functions can be defined from set A to set B. So how many number of functions can be defined from set A to set B. So please carefully note down this point. So number of functions from set A to set B. Set A to set B. So directly we will see the definition, formula. The number of functions from set A consisting of m elements to a set B consisting of n elements is equal to n power m. So n power m number of functions can be defined from set A to set B of having m and n elements respectively. So let's see one example here. So what is the example we have here is the number of functions f is 1, 2, 3, comma n to 2016, comma 2017, where n belongs to natural numbers, which satisfy the condition f of 1 plus f of 2 plus so on plus f of n is an odd number. Or so they are given options like this: 2 power n, b is n into 2 power n minus 1, c is 2 power n minus 1, d is n factorial. So this is one good question based on this concept, number of functions. So let's just see the solution. Actually, what they are given. Let's see information. So here we have the set A. So here we have set A, and this is our set B. So A is having 1, 2, 3, so on up to n, and the B is having only 2 elements, 2016 to 2007. So here the function f is different from A to B. So the function f is different from A to B. So how can we take this one? So what they told is A to B we have to define, and that should satisfy the condition that sum of these all means f of 1 plus f of 2 plus so on f of n is an odd number. So how can we take this? See, we can send this 1, 2, 3 up to n minus 1 anywhere in 2 power n minus 1 ways. So 2 power n minus 1 ways. So we should know a little bit permutations and combinations also. So here very clearly we can send 1, 2, 3 and so on up to n minus 1 anywhere in 2 power n minus 1 ways. 2 power n minus 1 ways. So what will be the value of n can be uniquely. So the sum of this all is even or odd. So Here it may be f of n plus f of 2 plus f of 3 plus so on plus f of n minus 1 can be belongs to even if f of n is in the 2017. So this belongs to odd when f of n is 2016. So therefore, number of functions from here, number of functions will be 2 power n minus 1 functions can be defined from set A to set B. So this is the one part. And another one. So what is the next? What is the next? We can take the topic is graphical test. So graphical test for this the functions. So let's see the graphical test of this one. So graphical test. So graphical test when it is a function or not. So here I will draw a few figures first of all. So I'll draw the figures, then we will discuss the points here. Let's see. This is y axis and this is x axis. So another also will take one more diagram. So this is y and this is x. This is x. So here for the first figure, so we have a parabola in shape like this, and we have a line which curves this like this. So this is y-axis, y dash, x, o, x dash. And let's see here again. This is y, y dash, x, o, x dash. So here I have one more line like this, and there will be one line which curves this. So which curves this. So like this. Okay. So here, see in these two figures. So how can we discuss the graphical test is? First, I'll write the point here. If the graph of a relation, if the graph of a relation, if the graph of a relation contains no 2 points on the same vertical line, then that relation is a function. So see here, if you observe the first figure, so this is a function because when you will draw a line vertically like this, so it curves this graph at one and only one point. So what is our definition? If the graph of a relation contains no 2 points on the same vertical line. So see here, for this graph, one and only one point we are having on this line. So that's why this is a function. So here this is also having only one line, one cut. So one intersection point, this is a function. Then when we cannot say it is a function. So if I take the graph like this, and so this is the circle. So if I'll draw a line, so like this. So see the circle having 2 points on this line. It cuts at two distinct places. So that's why it is not a function. So is there any other example to discuss it is not a function? Yes, we have. So that is like this. So I have two like this. So this is one graph. So when I will draw a line through this, so that line intersects this at two distinct points. So that's why this is also not a function. This is also not a function. So these two are not a function, and this is not a function, and these two are functions. So this is the way how we will do the graphical test for a function. So let's see officially how can we define the domain. So how can we define the domain of a function? So definition, domain of a function. The domain of y is equal to f of x. The domain of y is equal to f of x is the set of all real x, the set of all real x for which f of x is defined, for which f of x is defined. So simply if I take like f of x is equal to some x square by x plus 1. So this is true for all the x belongs to R except when x is equal to minus 1. దీని అర్థం ఏంటండి, ఈ ఫంక్షన్ మనం ఏ వాల్యూస్ సబ్స్టిట్యూట్ చేసినా నాట్ డిఫైన్డ్ అనేది రాకూడదు, అన్డిఫైన్డ్ అనేది రాకూడదు. బట్ దిస్ యూ విల్ గెట్ బికాస్ వెన్ యూ టేక్ x is equal to minus 1, it will become minus 1 whole square by minus 1 plus 1, which is 1 by 0, which is not defined. Except for that, for remaining all the real numbers, it is defined. So that's why, so how can we write the domain of this one is x belongs to all the real numbers except minus 1. X belongs to all the real numbers except minus 1. So this is the way how we will define the domain. So this is the example for this domain. And what are the rules? Rules for finding domain. Rules for finding domain. Rules for finding domain. So rule number 1. So first rule, if domain of y is equal to f of x, if domain of y is equal to f of x and y is equal to g of x, or d1 and d2, or d1 and d2 respectively, then the domain of f of x plus or minus g of x, or f of x into g of x is d1 intersection d2. అంటే ఈ రెండులలో ఉన్న కామన్ వాల్యూస్ ని మనము ఈ రిలేషన్స్ కి డొమైన్ గా కన్సిడర్ చేస్తామండి. సో ఇఫ్ f of x యొక్క డొమైన్ d1, g of x యొక్క డొమైన్ d2 అయితే రెస్పెక్టివ్లీ, if this f of x and g of x is related like f of x plus or minus g of x, అంటే ఆ రెండు ఫంక్షన్స్ యాడ్ అవుతునో సబ్ట్రాక్ట్ అవుతునో లేదా మల్టిప్లై అవుతునో ఉంటే వాటి డొమైన్స్ సపరేట్ గా కనుక్కొని, సో వాటి లేదా వాటి if it is possible, so we will simplify it and we will find out the common domain which satisfy both. So common values which satisfy both we will take as the domain of the whole function. That is symbolically how can we represent is like this: d1 intersection d2 will be the domain of these functions. This is a point number 1. So point number 2, domain of f of x by g of x, where g of x is not equal to 0, is d1 intersection d2. From here we have to remove the x for which g of x will become 0. అంటే ఇంతకుముందు ఎగ్జాంపుల్లో చూసాం కదండి, x square by x plus 1. So for this actually this is, let us think, this is a function. For this actually x belongs to R, all the real numbers satisfy this, but ఇది అన్ని రియల్ నెంబర్స్ సాటిస్ఫై చేస్తుంది, ఇది కూడా అన్ని రియల్ నెంబర్స్ సాటిస్ఫై చేస్తుంది. కానీ ఇక్కడ డినామినేటర్ లో x is equal to -1 if I substitute, so it will not be different. That's why we have to remove that -1 from the whole real numbers. So ఈ రెండు న్యూమరేటర్ అండి డినామినేటర్ సాటిస్ఫై చేస్తే డొమైన్ ఏంటి అంటే ఇక్కడ డొమైన్ ఆఫ్ దిస్ వన్ విల్ బి r minus -1, అంటే ఎక్సెప్ట్ ఫర్ -1 remaining all values we can take. సో ఇది డొమైన్ కనుక్కోవడానికి కొన్ని కండిషన్స్ అండి. సందర్భాన్ని బట్టి మళ్ళీ మీకు డిఫరెంట్ టెక్నిక్స్ అక్కడ చెప్తాను ఎలా కనుక్కోవాలి అనేది. సో ఫస్ట్ లెట్స్ సి ఎగ్జాంపుల్స్ హియర్, some more examples based on the topics what we discussed now. That means especially domain. Find the domain of y is equal to root over 5x minus 3. Y is equal to root over 5x minus 3. So I'm taking the general examples to find out the domain, how to find the domain for basic problems. So find the domain of y is equal to root over 5x minus 3. General and first, after giving the function, we have to check, so is there any special function is appearing in our question? Yes, a special function, that is a root function. Here we have the square root. So generally we know inside the values of square root, it is defined for when is this square root is in numerator. So we have to take it is greater than or equal to 0. That should be always greater than or equal to 0. So when the same square root if you have in the denominator, means like 1 by root over 5x minus 3, then it will be only greater than 0, because when it will become 0, 1 by 0 is not defined. 1 by 0 is not defined. So కాబట్టి ఈ రెండు విషయాలు గుర్తుపెట్టుకోవాలి. సో ఈ రెండు విషయాలు ఏంటంటే, when the square root is in the numerator, that square root is defined for when 5x minus 3 is greater than or equal to 0. And లోపట square root లోపట ఉన్న వాల్యూ greater than or equal to 0 అయినప్పుడు మాత్రమే ఆ స్క్వేర్ రూట్ ఫంక్షన్ అనేది డిఫైన్ అవుతుంది. సో ఫ్రమ్ హియర్ వాట్ వీ కెన్ రైట్, 5x is greater than or equal to 3 and x is greater than or equal to 3 by 5. సో x is greater than or equal to 3 by 5 అంటే ఏంటండి, ఇది 0, ఇది 3 by 5 అంటే, సో ఇక్కడ నుంచి ఈ మొత్తం వాల్యూస్, సో ఇంక్లూడింగ్ 3 by 5, ఎందుకంటే గ్రేటర్ దెన్ ఆర్ ఈక్వల్ టు అన్నాడు కాబట్టి హియర్ వీ కెన్ కీప్ ద క్లోజ్డ్ సర్కిల్ వెన్ దట్ వాల్యూస్ ఆల్సో ఇంక్లూడ్. సో దేర్ ఫోర్ domain is closed interval 3 by 5 to the infinity for all the values that y is equal to root over 5x minus 3 satisfies. సో ఇక్కడ మనకి ఈ క్లోజ్డ్ ఇంటర్వెల్ ఓపెన్ ఇంటర్వెల్ అనేది చాలా క్లారిటీ ఉండాలండి. సో సిన్స్ ద సిచ్యువేషన్ కేమ్ ఐఎమ్ డిస్కసింగ్ అగైన్ అబౌట్ దిస్ క్లోజ్డ్ ఇంటర్వెల్ అండ్ ఓపెన్ ఇంటర్వెల్. సో ఇక్కడ క్లోజ్ ఇంటర్వెల్ అంటే ఏంటి అని అంటే, ఇఫ్ ఐఎమ్ టేకింగ్ సమ్ పాయింట్ 2, 10, సో హియర్ నేను 2, 3, 4 ఇలా అంటే వీటి మధ్యలో ఉన్న వాల్యూస్ కూడా తీసుకోవచ్చు అప్ టు 10. అంటే ఈ 2ని 10ని కూడా మనం ఈ ఇన్పుట్లో ఇంక్లూడ్ చేస్తామండి. సో వీ కెన్ ఇంక్లూడ్ దిస్ 2, 10 ఆల్సో. సో ఇఫ్ ఐ హ్యావ్ సేమ్ థింగ్ లైక్ ఓపెన్ ఇంటర్వెల్, సో దిస్ ఇస్ కాల్డ్ క్లోజ్డ్ ఇంటర్వెల్, ఓకే. సో దిస్ ఇస్ కాల్డ్ ఓపెన్ ఇంటర్వెల్. సో ఓపెన్ ఇంటర్వెల్, సో దిస్ ఇస్ ఓపెన్ ఇంటర్వెల్. హియర్ 2ని తీసుకోమంటే 2ని 10ని తీసుకోమంటే 2 పాయింట్ నుంచి స్టార్ట్ చేస్తాము అప్ టు 9.99 ఎక్సెప్ట్ దిస్ 10 అండ్ దిస్ 2. సో 2ని 10ని తీసుకోకుండా మిగిలిన అన్నిటి వాల్యూస్ తీసుకోవాలని చెప్పేసి ఈ ఓపెన్ ఇంటర్వెల్. నెక్స్ట్ క్లోజ్డ్ అండ్ ఓపెన్ అంటే ఒక సైడ్ క్లోజ్డ్ ఉంటుంది, ఇంకో సైడ్ ఓపెన్ ఉంటుంది. అంటే ఇక్కడ ఏంటి, ఇక్కడ 2ని ఇంక్లూడ్ చేయాలి, ఇంక్లూడ్ ద 2 అండ్ ఎక్స్క్లూడ్ ద 10, రిమైనింగ్ ఆల్ వాల్యూస్ తీసుకుంటాం. సో ఓపెన్ అండ్ క్లోజ్డ్ మీన్స్ 2 to 10 క్లోజ్డ్, ఇక్కడ 2 ఎక్స్క్లూడ్స్ అండ్ 10 ఇంక్లూడ్స్, ఇలా డిఫరెంట్ బ్రాకెట్స్ ఉంటాయండి. సో ప్లీజ్ రిమెంబర్ దిస్ ఆల్. లెట్స్ సీ వన్ మోర్ డిఫరెంట్ ఎగ్జాంపుల్ హౌ టు ఫైండ్ ద డొమైన్. సో ఎగ్జాంపుల్ 2, y is equal to cube root of 5x minus 3. y is equal to cube root of 5x minus 3. సో ఇక్కడ క్యూబ్ రూట్ అండి, ఈ క్యూబ్ రూట్ ఈస్ డిఫైన్డ్ ఫర్ ఆల్ ద రియల్ నెంబర్స్. సో దీని గురించి మీరు ఏం వరీ అవ్వాల్సిన అవసరం లేదు, ఎందుకంటే నెగిటివ్ వాల్యూస్ కూడా ఎగ్జిస్ట్ అవుతాయి కాబట్టి. సో క్యూబ్ రూట్ ఈస్ డిఫైన్డ్ ఫర్ హియర్ x belongs to all the real numbers. So therefore domain of this one will be all the real numbers. So let's see the another example that y is equal to 1 by x minus 1 into x minus 2. సో 1 by x minus 1 into x minus 2. సో ఇక్కడ స్క్వేర్ రూట్ లేదు లేదా లాగరిథమ్స్ కానీ ఇంక ఏ ఫంక్షన్ కూడా ఇక్కడ లేదండి. సో ఇట్ ఈస్ సింప్లీ అన్ ఆల్జీబ్రిక్ ఎక్స్ప్రెషన్, బట్ that algebraic expression is in the denominator. So that's why we have to check carefully that. So when this will become 0, అంటే x minus 1 into x minus 2 0 ఎప్పుడు అవుతుంది అంటే x is equal to 1 కి అండ్ x is equal to 2 సబ్స్టిట్యూట్ చేసినప్పుడు ఇది 0 అవుతుంది. కాబట్టి దిస్ ఈస్ ట్రూ ఫర్ ఆల్ ద రియల్ నెంబర్స్ ఎక్సెప్ట్ 1, 2. అంటే ఈ 1, 2 సబ్స్టిట్యూట్ చేసినప్పుడు తప్ప in every pair it will be different. So that's why the domain of this y is r minus 1, 2. సో ఈ బ్రాకెట్ అండి, ఈ బ్రాకెట్ ఇక్కడ ఒక మీనింగ్ ఉందండి. ఏంటి బ్రాకెట్ మీనింగ్? ఇక్కడ ఇలా మనకు ఫ్లవర్ బ్రాకెట్స్ ఉంది అని అంటే అర్థం ఏంటంటే ఓన్లీ ఈ 1, 2 మాత్రమే తీసుకోవాలి అని అర్థం. సో డిఫరెన్స్ అదేనండి. అదే బ్రాకెట్ ఇలా ఉందనుకోండి, ద వాల్యూస్ బిట్వీన్ 1 and 2. అదే బ్రాకెట్ ఇలా క్లోజ్ ఉందనుకోండి, ద వాల్యూస్ బిట్వీన్ 1 and 2 ఇంక్లూడింగ్ 1 and 2. సో ఇలా ఫ్లవర్ బ్రాకెట్స్ ఉన్నప్పుడు వాటి మధ్యలో ఉన్న వాల్యూస్ తీసుకోవద్దండి. ఓన్లీ దట్ 1, 2 వీఆర్ రిమూవింగ్ ఫ్రమ్ ద ఆల్ ద రియల్ నెంబర్స్. సో ఎక్సెప్ట్ దట్ 1, 2 meaning all are the domain of this function. So hope everyone understood with these examples. So how can we find the domain of the functions, the small functions? So ఇంకా నెక్స్ట్ టాపిక్స్ వచ్చిన కొద్దీ మనం ఈ ప్రాబ్లమ్స్ బేస్డ్ ఆన్ ద డొమైన్ we will discuss more number of problems అండి. So first we will introduce different kind of functions here. So let's see the classification of functions. Classification of functions. So classification of functions. So let's see classification. How many different types of functions we have? One is we have algebraic functions. We have algebraic functions. So in this we can take like monomial function, polynomial function, next rational function, and next irrational functions. So irrational algebraic functions. So under this polynomial again we have constant function and identity function. So identity function. So next transcendental functions. Next is transcendental. So transcendental functions. In this we have exponential functions and logarithmic functions, and we have trigonometric functions under this category, and we have inverse trigonometric functions. So next piecewise functions. So third category is piecewise functions. So under this you'll get modulus functions, signum function, and greatest integer function, and a fractional part of a function, and least integer functions. So least integer function. So in this we'll see today algebraic first type, algebraic functions. So let's discuss the algebraic functions. So in this video, so let's see, heading is algebraic functions. So what is meant by algebraic functions here? So like f of x is equal to root 1 plus x. This is an algebraic function. G of x is equal to x cube minus 16x by x plus root x plus x minus 2. This is one algebraic function. So like this. So how can we define algebraic function? Is a function f is called an algebraic function. A function, so definition I'm writing here. a function f is called an algebraic function. An algebraic function f is called an algebraic function if it can be constructed using algebraic operations using algebraic operations such as addition, subtraction, multiplication, division, and taking roots starting with polynomial. So examples వచ్చేసి పైన రాసానండి, starting with polynomials. So this is the definition. So under this, what is called monomial? So monomial is a function of the form y is equal to a into x power n, where a is a constant. So n is a non-negative integer. So simple example, we can write y is equal to x square, y is equal to 2x, y is equal to minus x, and so on. These are all monomials. So simply that form it is consist. Next, what is mean by polynomial function? So a function of the form y is equal to f of x, that is a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus 1 up to an, where a naught is not equal to 0 and a naught, a1, a2, and so on an are real constants, and n is non-negative integer. then f of x is called polynomial function. This is already we will learn in the 10th class, so in the polynomials chapter. So a simple example I can take, like, so example, f of x is equal to x power 3 plus 5x square plus 3, or we can take some f1 of x is equal to x power 1920 plus 5x power 1919 plus 6x, so like this. So these are called some examples of polynomials. So let's see how to draw the graph of polynomial functions and finding their domain and range. So by using the graphs, how to find out the domain and range of the polynomial functions. So let's see. Here we'll take one question like y is equal to x plus 1. So how to draw the graph for this one? First I'll see tabular form. Let's take the tabular form. So what is the tabular form? Here I'm taking this, since it is a straight line, simple line, I'll take x and y. Just once I'll take x is equal to 0. So if I'll take x is equal to 0, y is equal to 1. When I will take y is equal to 0, x is equal to minus 1 will get. So we'll draw the graph for this one in simple way. So like this. So we can understand the what is the domain and range of this one. So like this I'll take. So where it curves is on x-axis at 1, 0. 0, 1, right? 0, 1, minus 1, 0. 0, 1 means that is point lies on y-axis. Minus 1, 0 means that point is lies on x-axis. So if we'll join these two, so the graph of y is equal to x plus 1 will be like this. So what is the domain? What is the domain here we have for this one? This is true for all the real numbers. What is the this one? It is true for all the real numbers. Here for different values of the x, we'll get the different values of the y. Different values of the y. So we cannot say exactly what is the range. So it is real, all the real numbers we will get. So domain is also real numbers and range also real numbers. So let's see graph for one more question. That is y is equal to x cube plus 1. Y is equal to x cube plus 1. So if we draw the graph for this one, so let's see how we will get the graph for this one. Let's take x-axis and y-axis. So x o x dash and y o y dash. So here I'll assume 1, 2, 3, 4 because it is a cubic equation. So let's try with the different examples, different numbers. So what we'll get? So here this is 1 and 2 and 3 and 4 like that. So here also this side minus 1, minus 2, minus 3, minus 4. So I'll take the tabular form here. I'll take the tabular form like this. So let's take the tabular form. And for every x value, there will be different value. So if I'll take x is equal to 0, y is equal to 1. If I'll take x is equal to 1, y is equal to 2, y is equal to, if x is equal to 2, x is equal to 2, y is equal to 8 plus 1, 9 will get. So next, if I'll take minus 1, so you'll get 0. And if I'll take minus 2, you'll get minus 7. So let's see 0 comma 1, 0 comma 1 in the sense it will be here 0 comma 1 and 1 comma 2 will be here and 2 comma 9 is somewhere here. Okay, and minus 1 comma 0 will be here and minus 2 comma minus 7 will be some more down this side. So if you join this with a free-handed curve, so the curve will be like this. The curve will be like this. So this is a free-handed curve. This is a free-handed curve. So it is true for all the real numbers. So domain is real numbers only, and the range also you will get different real numbers. So this is the way how we will draw the graph for y is equal to x cube plus 1. So for y is equal to x square. So for y is equal to x square, how to draw the graph? So how to draw the graph? So let's see first tabular form. First we'll take the tabular form. Then based on the tabular form, we'll draw the graph of this one. Y is equal to x square. So x, y. So if x is 0, y is 0. If x is 1, y is 1. If x is minus 1, y is also 1. X is 2, y is 4. Minus 2, 4, 3, 9. So minus 3, minus, 9 only. So here, let's see what are the pairs 0, comma 0, 1, comma 1, minus 1, comma 1, 2, comma 4, and minus 2, comma 4, 3, comma 9, and minus 3, comma 9. So these are the points what we have to plot on the coordinate system, and we should draw the graph. So let's take the x-axis and y-axis. So this is our y-axis and this is our x-axis. So this x-axis let's take a little bit down because we are not getting any negative values for y. So now this is x o x dash and this is y o y dash. So what are the points we will take here is like 1, minus 1, minus 2, minus 3, minus 4 enough, 1 and 2 and 3 and 4. So this side of what we have up to 9. So 1, 2, 3, 4, 5, 6, 7, like that we have. So let's plot the points here. First 0, comma 0. Here it is 1, comma 1. Here it is minus 1, comma 1. So here 2, comma 4 somewhere here, minus 2, comma 4 again here, 3, comma 9. So we cannot say somewhere here like this 3, comma 9. So this is the free-handed curve. So we can draw the graph like this. So we can join neatly, and we can extend like this, and this is also up to 4, and it will go in. So this is called parabola. So parabola. So this is the graph of y is equal to x squared. So the graph of a quadratic polynomial. Therefore, the graph of a quadratic polynomial is parabolic in shape. Parabolic in shape. So particularly for this y is equal to x squared, domain is all real numbers. Domain we can take any value, but range is only non-negative integers, non-negative values. అంటే జీరో వస్తుంది, పాజిటివ్ వాల్యూస్ వస్తాయి, బట్ నెగిటివ్ వాల్యూస్ రావు. ఎందుకంటే ఓన్లీ వీ హ్యావ్ ఎక్స్ స్క్వేర్ టర్మ్. సో దిస్ ఇస్ ద వే. సో హౌ వీ కెన్ డ్రా ద గ్రాఫ్ ఆఫ్ polynomial. So under this we have two different types. One is constant function, another one is identity function. So let's see that. So first constant function, let's see. So constant function. So first let's see constant function. If the range of a function f consists of only one number, so మనం ఏ సబ్స్టిట్యూట్ చేసినా అవుట్పుట్ ఒకటే నెంబర్ ఉండాలి. So that kind of functions are called constant function. So how can we define here? If the range of a function, f consists of only one number, అంటే ఒకటే ఒక అవుట్పుట్ ఉండాలి, then f is called a constant function. Then f is called a constant function. So how it will be the graph for this? So let's see how it will be the graph for this a constant function. So let's assume this is y o y dash, and this is x o x dash. So for example, y is equal to 2, no, y is equal to some f of x is equal to c. How to draw is like this one, which is parallel to x-axis. This is f of x is equal to c, or y is equal to c, we can say. Y is equal to c, we can write. So domain is, you can substitute anything, but range you will get only c. There will be no change in the output. These kind of functions are called constant functions. Next, identity function. Next is identity function. So what is meant by identity function means whatever you'll substitute, you'll get again same output. Means if you will substitute 1, you should get 1 output. If you substitute 2, output will be 2. So like this, then it is called identity. So simply how can we define is the function y is equal to x for all x belongs to R is called an identity function. On R. So y is equal to f of x lo నేను ప్లేస్ సబ్స్టిట్యూషన్స్ రండి. If x is equal to 1, y is equal to 1. If x is equal to 2, y is equal to 2. If x is equal to 0, y is equal to 0. If x is equal to -1, y is equal to -1. So it's like mirror. So it will show the same image. So these kind of functions are called identity function. So the graph of identity function will be like this. The graph of identity function will be like this. So it will pass us through the origin. So here, like this is 0, 0, somewhere 1, 1, 2, 2, 3, 3. So here this will be -1, -1, -2, -2. Like this, the points lies on this one. So Therefore, how can we finalize the domain of this one? So domain of this function is R, and a range also R. So this is the way how we will discuss the domain and the range of the polynomial function. Under this algebraic functions, we have two more, that is a rational function and irrational functions. So let's see that rational function under the category of algebraic functions. What is meant by rational function is if any function f of x is in the form of p of x by q of x, where provided condition q of x is not equal to 0, is called a rational function. So a simple example I will give you. F of x is equal to x square minus 3x plus 5 by x minus 1 into x minus 2. So how to find the domain of these kind of rational functions is, so it is true for all the real numbers except where this denominator becomes 0. So where the denominator becomes 0, so for 1 and 2 it becomes 0. So if you remove that 1 and 2 from the real numbers, that will be the domain. So what about the range? We cannot say particularly. So range will be depends on the problem. So problem to problem, range of the rational functions changes. So range of the rational functions changes. So this is what. Next, what is irrational function? What is irrational functions? Irrational function. So your irrational function is the function which is consist of powers of not integers. So like rational numbers. So f of x is equal to x power 1 by 2. F of x is equal to x square plus root x by root over 1 plus 3x square. These kind of functions are called irrational functions. So irrational functions. So these are the classification of functions. First part, algebraic functions. So with different examples we will discuss in the next video. So please keep watching my video. So whatever we discussed till now, for everything we are going to solve in the problems with the transcendental functions, which are very, very important. After that we have piecewise functions, so which rules the IIT. So please keep watching my next videos also to get the easiest examples to toughest examples with all the concepts. So thank you all for supporting my videos and to see my videos, and please subscribe to my channel for more videos. Thank you all.